Hello, this is Elizabeth from the Academic Support Center at Raritan Valley Community College. I was just going to go through this is the first part. We'll start going through the questions on the Pre-Calc 2 review for the end of the semester. We'll see how far we can get before we have to stop. So the first question was converting 240 degrees to radians. So when we convert degrees to radians, we're always going to multiply times pi over 180 because there's pi radians in 180 degrees. So if we do this, we get 240 pi over 180. Okay, we can simplify this. We can divide both the top and the bottom by 60. So 240 divided by 60 becomes 4 pi. 180 divided by 60 is 3. So that is our answer, 4 pi over 3. So again, the key here is that we're multiplying by pi over 180. If we're going from radians to degree, we want to multiply by the reciprocal, so 180 degrees over pi. Okay? The second question was they wanted the exact points for x and y on the unit circle for negative pi over 4. So I'm very graphical, and I just like to have my unit circle here, and we're looking at negative pi over 4. So this angle here is negative pi over 4. So you want the x and the y here. So some people love to memorize the unit circle. If you memorize the unit circle, you know that this point is going to be square root of 2 over 2 and negative square root of 2 over 2. I have a hard time just memorizing random things. When I look at this, I see this. This angle is pi over 4, so this angle has to be pi over 4. So this is equal to this. If we set this equal to 1, 1, we have our hypotenuse is going to be, we use the Pythagorean Theorem, so 1 squared plus 1 squared is going to equal c squared. So our c squared is equal to 2, so our c is equal to the square root of 2. Okay, and then if we multiply, what do I want to say? So that's our angle, but to get the point on our unit circle, this becomes sine of theta is going to be 1 over the square root of 2, but we want to normalize that. So we multiply by the square root of 2 over the square root of 2. This is equal to the square root of 2 over 2. And the y value is negative because we're down, but it's going to be the same thing. That's a little aside. If you like memorizing the unit circle, by all means, go ahead and memorize it. And that one is there. This next problem was it gave you theta is equal to negative 5 pi over 6, and we wanted to find all 6 trigonomic functions of this. So again, if we look, sorry about that, if we look at our unit circle, and we are at negative 5 pi over 6, that's over here, right? So our reference angle is pi over 6. This point, if we memorize our unit circle, is negative square root of 3 over 2 and negative 1/2. Again, a little aside, this pi over 6 is 30 degrees. So we start with an equilateral triangle. We divide it in half. If our sides were 2, this one's divided in half. It's 1. And this is the square root of 2 minus the square root of 1. So this is the square root of 3. And we're looking at this 30-degree angle. So the cosine of this angle is the square root of 3 over 2. And it's going to be negative because we're in the quadrant, that quadrant. Our sine of this angle is going to be 1 over 2. And again, that's going to be negative. Okay, so if this is our point on our unit circle, we know this is cosine sine, right? So our sine is just -1/2. Our cosine is just the x coordinate, -√3/2. Okay. Our cosecant is the inverse of our sine, so we're going to take the reciprocal of the sine, so it's going to be 2/1 or just 2. And our secant is going to be 1 over our cosine. So we're going to take the reciprocal of our cosine, which is, just going to write this over here, secant theta is going to be the reciprocal, so this is going to be -2/3, but then we need to normalize this, √3 times √3. So this is going to be 2√3/3, and this is going to be negative. So that's our secant, -2√3/3. And our tangent is just going to be, our tangent is our sine over our cosine. So tan of theta is going to be our sine, which is -1/2, divided by our cosine, -√3/2. So when we divide by a fraction, it's like multiplying by the reciprocal. So this is -1/2 times the reciprocal of 3/2 times -2/3. So our 2's are going to cancel out. Our negative times negative is going to be positive. So this is equal to 1/3. If we normalize that by multiplying the top and the bottom by the √3, we get tangent is equal to √3/3. And our cotan is 1 over our tangent. So I'm actually going to go back to this portion here before we normalized our denominator. So we have 1 over the √3. So our cotan is just going to be the √3. Okay? So again, find the point on the unit circle, find the coordinates, our sine and our cosine. We're using our reciprocal functionalities for our cosecant and our secant and our cotan, and our tan is just our sine over our cosine. Okay? So number 4, it said sine theta is equal to -2/5, or is equal to 2/5. And so we wanted to find sine of negative theta. And there's a couple of identities. I'm just going to write them down over here. Is that sine of negative theta is equal to the negative of sine theta. Likewise, cosine of negative theta is just equal to cosine of theta. Okay? There's a couple ways to think about this, to remember this. If you're formula-based, absolutely remember this formula. If you are not, if you're like me in your graphic, I always say, so if this is some angle theta, this is going to be my negative theta. We have a point here. This is xy. Okay? This point here, it has the same x value, but it's going to be equal and opposite -y. Okay? So our cosines are the same, but our sines are opposite value. So here we have sine negative theta. This is going to be the negative of our sine theta. So this is just going to be -2/5. Okay? And the other functionalities that they're invoking here are the reciprocal functions. So cosecant is 1 over sine. So I'm just going to write this down. Cosecant theta is 1 over sine theta. And our secant theta is equal to 1 over cosine theta. So in this case, we're just going to take the reciprocal of 2/5, which is 5/2. Okay? Okay. This last one that I think we can squeeze this one in here. This last one is cosecant of theta is equal to 7/3. So again, sine theta is is the reciprocal of cosine theta. So we're just going to take the reciprocal. This is 3/7. And now we have to find cosine theta. And there's two ways we can do this. We can draw a triangle, or we can use our Pythagorean identity. So if we draw a triangle, we have an angle theta on a right triangle, and sine is opposite over hypotenuse. So it's opposite over hypotenuse, 3/7. And now we can use our Pythagorean theorem to find this cosine, this opposite, this leg of our triangle. So this is a. So a squared plus 3 squared equals 7 squared. Or a is equal to the square root of 7 squared minus 3 squared, which works out to be 7 squared is 49 minus 9 is 40. So this works out to be the square root of 40, and we can simplify this as 4 times 10, so 2 times the square root of 10. So this is 2 times the square root of 10. So now if we say cosine is our adjacent over our hypotenuse, this becomes 2 square root of 10/7. The other way we can do this is we can invoke, or we can use our Pythagorean identities. So that is our sine squared theta plus cosine squared theta is equal to 1. So when we do this, we know sine is 3/7. So 3/7 squared plus cosine squared theta is equal to 1, or cosine squared theta is equal to 1 minus 3/7 squared. So 3 squared is 9. This is over 49. And again, this is going to equal 1 is 49/49 minus 9/49. And then we're going to take, this is equals 40/49. This is our cosine squared, so we can take the square root of both sides. That becomes cosine theta is equal to the square root of 40, which we did up here, which is 2 square roots of 10, divided by the square root of 49, which is 7. So we get the same answer either way. Different people like different methods, so they're both here. So I will continue this in an additional video, but if you need help beyond what's here, please feel free to reach out to the Academic Support Center.